This is tutorial 3 under node voltage method. In this video too, we are going to analyze this circuit to get our node voltages V1, V2 and V3. In this diagram, the reference node is already given. It is grounded, so this represents what? Our reference node. The down part here is our reference. So we are interested in getting the values for V1, V2 and V3 using the node voltage method. So we have to assign current to the non-referenced node, which is the V1, V2 and V3. But looking at this branch, there is already a current giving what? 5 amperes, which is entering. So I'm not going to assign current here because the current is what's given. Its value is given. So I can assign current on this branch in any direction I want. So let me call this one I1. Current on this branch I2. There's another branch, let's say current what? I3. On this branch, the current value is already given to be what? 3 amperes. So let's consider this branch. I have another current. Let's say it is moving in this direction. I4. On this branch too, I have to assign what? Current. So let's say it is moving down what? I5. Now I'll come to this branch too. Since there is a voltage source here and the positive is here, let's say we are using the conventional current flow. So let's say the current will be moving up. It is an arbitrary direction we are taking. So let's say I'm saying the current here is what? I6, which is moving up. Someone can say the I6 is what? Moving down. The person is not wrong. So we are now going to write what? The KCL at the unknown node. We have 3. So let's write KCL at all of them. So KCL at node 1. So looking at this node, how many branches are making up this node? We have a lot of them. Look at this branch here. This branch is connecting here and here. This is not what? A branch. So what I can do is I can put this node here. I can put this wire here, connect it to what? This junction here. I can also put the end or put the end of this branch here, connect it what? To this junction here. This diagram is the same as the previous one. We've not changed anything. So the node here, that is node 1, is made up of how many branches? 1, 2, 3, 4, 5. They are made up of what? 5 branches. So it means you have to get 5 currents because each current will be on what? Each branch. So let's see the current which are entering. We have the 5 amperes entering. I1 is leaving, I2 is leaving, I3 is what's leaving. And what? 3 amperes is also leaving. So I have 5 is equal to I1 plus I2 plus I3 plus 3 amperes. So these values are given. Now we have to express the current here in terms of the node voltages. So we can simplify. Let's say 5 minus 3 is giving us what? 2 is equal to what is I1? I1 is the current here. So the node V1 to where? The reference. They are all moving to the reference. So I have V1 minus 0 over the resistor. So it's the same as V1 over what? 4. Then plus, what is V2? What is I2? Sorry. I2 is starting from V1 to where? V2. So V1 minus V2 over which resistor? 8. Plus, what is I3? I3 is starting from node V1, moving all the way to where? Node V3. So I have V1 minus what? V3 over resistor what? 2. So we can simplify this equation. The LCM is what? 8. So let's multiply 3 by 8. 8 by this one is giving us 16. 8 by here is giving us 2 V1 plus V1 minus V2 plus 8 multiplying this one is giving us 4 V1 minus 4 V3. Let's group like terms. So V1 is giving us what? 7 V1. We have minus V2 minus 4 V3 is giving us what? 16 as our first equation. We just group like terms here. 7 V1 minus V2 minus 4 V3 is equal to 16 volts here. So the next thing is to do what? Write the KCL at the next node. So KCL at node 2. KCL at node 2. So at node 2, we have how many branches making up that node? We have 3. It means we need to get 3 currents. So which of the current is entering? At this node I have I2 entering, I5 leaving, I4 leaving. So I2 is equal to I4 plus what? I5. Let's express each of the currents. I2 is what? V1 minus V2 over resistor 8, giving me I4. I4 is also what? V2 minus V3. So V2 minus V3 over which resistor? 4 plus I5. I5 is starting from V2 to where? The reference 0. So V2 minus 0 over 2, which is the same as V2 over what? 2. Now let's multiply through by what? The LCM. So we can use 8 as the LCM here. So this place by 8 is giving us V1 minus V2. This place by 8 is giving us 2V2 minus 2V3. This multiplying 8 is giving us what? 4V2. So we can group like terms here. We have V1. So let's group the V2. We have minus, 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 giving us minus 7 V2. And we have what? Plus 2 V3 is equal to 0. We are just grouping our items. So V1 is here. I'm bringing all the variables here. So I have minus 7V2 plus 2V3 is equal to 0. Now we are going to write KCL at the last node. So KCL at node 3. So at node 3, how many branches are making up that node? We have 1, 2, 3, 4. 4 branches, meaning we have to get what? 4 currents. So looking at the branches, which of the currents are entering, which ones are leaving? You realize on this branch I have 3 amperes entering. On this branch I have I3 entering. On this branch I have I4 entering. This branch I have what? I6 entering. So all the currents are what? Entering. So I have 3 plus I2 plus I4 plus I6 giving me what? 0. All the currents are empty. So let's express the currents. I have 3 plus, what is I2? What is I2? We don't have I2, sorry, it is I3 we are talking about. That is what? I3. So I3, I4, I6. What is I3? We've already expressed I3. I3 is V1 minus V3. So V1 minus V3 over resistor 2 plus I4. I4 is from V2 to where? V3. So we have V2 minus V3 over resistor what? 4 plus I6. I6 is starting from where? The 12 volts to the node what? V3. Or you can say 0 minus V3 plus 12, which is the same as 12 minus V3, which is 12 minus V3 over what resistor? Resistor what? 8. Good. Is equal to what? 0. So what is the LCM here? You can say the LCM here is what? 8. So let's multiply through by 8. This by 8 is giving us 24 plus this portion by 8 is giving us 4V1 minus 4V3 plus this portion multiplied by 8 is giving us 2V3 minus 2V2 minus 2V3. This portion multiplied by 8 is giving us what? 12 minus V3 is equal to 0. So let's group our items. I have V1, I have 4V1 here. What is V2? I have V2 here, so plus 2V2. Let's add our V3. Have V3 here, V3 here, another V3 here, giving me minus 7 what? V3. So 4V1 plus 2V2 minus 7V3 is equal to what? So we have 24 plus 12, which is giving us 36. So I'm sending it to the other side, which is what? Minus 36. So this is our third equation. This is our second equation. So what have we done? We've just written KCL at the unknown nodes, and then we've expressed each of the currents in terms of what the node voltages. That's all node voltage method is about. So from here we are supposed to calculate for what the V1, the V2 and the V3. So I will use my calculator to calculate the node voltages. So from equation 1 I have 7 minus 1 minus 4, 16. Equation 2 I have 1 minus 7, 2, 0. Equation 3 I have 4, 2, minus 7 and what? Minus 36. So it means my V1, after solving, your V1 is what? 10 volts. Your V2 is 4.933 volts. And our V3 is what? 12.267 volts. So these are the node voltages we've arrived at using the node voltage method. So if you were asked to find the current on each branch, then if you want I1, you know what to do. It is V1 minus the 0 over 4, and that one will help you to get the current through each of the resistors. Thank you very much for watching this tutorial video.